the Research Center for Ecology and Ethnobiology, Head of the Research Center of Agriculture and Food and Staff, Head of the Research Center of Remote Sensing and Staff, Head of the Research Center of Behavior and Circular Economy and Staff, Directorate General of Watershed Management and Forest Rehabilitation or Delegation, Instrument Standardization Agency or Delegate, Directorate of Environment of Bappenas or Delegate, Deputy for Planting and Evaluation Fit and Mangrove Restoration Agency for Delegate, Directorate of Pit Ecosystem Domain Control of Delegate, Directorate of Greenhouse Gas Inventory or Delegate, Head of the Center for Standardization on Disaster Release and Climate Change Instrument or Delegate, ICRA Program Indonesian or Delegate, C4 or Delegate, Nusantara Natural Conservation Foundation or Delegate, PT Rimba Makmur Utama or Delegate, Waterland International Indonesian or Delegate, and Indonesian Science and Technology Friend. Welcome to the first Exportal series. The theme Soil as Carbon Storage and Sinks, Expectation, Patterns, Process, and Prospect or of Transition, present by the Research Center for Ecology and Ethnobiology of the National Research and Innovation Agency. Good morning, Dr. Meine, and all participants. How are you today? May you always be healthy and always in good protection. Thank you. Ladies and gentlemen, I'm Resti Ura. Saya adalah peneliti ahli pertama dari Research Center for Ecology and Ethnobiology as master ceremony of the first Exportal series this morning. I will guide the event using bilingual language, English and Indonesian. Now, ladies and gentlemen, the order of our schedule this morning, the first event was a speech from the head of the Research Center for Ecology and Ethnobiology by Dr. Anang Setiawan Ahmadi, as well as opening the first Exportal series. The second event is the reading of curriculum vitae and brief material from the speaker by the moderator, Dr. Made Hestilestaritata. Third, presentation of material by Dr. Meine van Noordwijk from ICRAF World Agroforestry. Fourth, discussie 50 awarding certificate to speaker and closing. The next event was a speech and opened by the head of the Research Center for Ecology and Ethnobiology by Dr. Anang Setiawan Ahmadi. Please welcome Dr. Anang. Pak Kapus.
Yeah, thank you very much, Bu Resti. First of all, I would like to thank to Dr. Meine to spend the time today. Maybe is it okay for me to speak in bahasa, Pak Meine?
Silakan. Kalau bahasa Jawa, button.
As I know that you've been in Indonesia for a long time, so I think you fluent in bahasa well. So yeah, selamat pagi dan saya ucapkan terima kasih Dr. Meine untuk waktunya yang pada pagi hari ini sampai siang nanti akan berbagi ilmu, kemudian yang saya hormati Bapak, Ibu, pejabat ataupun yang mewakili dari tadi yang sudah disebutkan oleh moderator dari Direktorat Jenderal, kemudian dari BSI atau dari Pustanpi atau Pustarhut. Saya ucapkan terima kasih yang sudah meluangkan waktu, karena alhamdulillah pada hari ini kita bisa melaksanakan yang kita namakan expert talk, di mana untuk pagi ini Dr. Meine akan banyak berbagi ilmu terkait soils as a carbon store and sinks, expectation, patterns, processes, and prospects of transition. Saya pikir ini sangat penting karena memang the global issue related with the climate adaptation and mitigation right now is still as a hot issue, not just nationally, Dr. Meine, but also internationally. Dan terutama karena terkait dengan komitmen Indonesia menaikkan NDC, kemudian target komitmen Volunetsing 2030, kemudian juga net zero emission di 2060, dan ini penting bagi kita. Aspek-aspek atau aspek ilmu apa saja ataupun kawasan-kawasan atau sebenarnya apa saja yang bisa kita gali dari research dan inovasi ini untuk kita bisa optimalkan, terutama untuk mendukung komitmen nasional. Tanpa berpanjang lebar, saya pikir karena mungkin banyak yang sudah penasaran juga ingin tahu, dan Pak Men mungkin nanti bisa juga dalam bahasa Indonesia ya Pak Men ya. Jadi mudah-mudahan kita dan pesertanya saya kira 99% ini pinginnya dalam bahasa kayaknya, biar mereka cepat menyerap ilmunya Pak Men. Tapi it's okay, but if you mix it with English, but dan di sini juga ada pakarnya dari BRIN, Bu Made Hesti, saya pikir juga dari bisa menambahkan
Ayo aku tanya John dan atau
riset-riset ataupun kegiatan yang sedang dilakukan maupun yang pernah dilakukan sebelumnya. Saya pikir itu pengantar dan sekaligus membuka acara expert talk dari Dr. Mein, dan mudah-mudahan bisa bermanfaat dan mudah-mudahan juga bisa membuka peluang kita untuk berkolaborasi di masa yang akan datang. Demikian, terima kasih, thank you very much, dan selamat menikmati, mudah-mudahan kita bisa mendapatkan manfaat yang dari acara pagi ini. Terima kasih, secara resmi saya buka. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Pak Kapus. The next agenda, their participant will conduct photo session. Mohon Bapak Ibu sekalian mengaktifkan kamera untuk kita berfoto bersama. Saya meminta tolong Bapak Isamil untuk memandu jalannya sesi foto bersama.
Baik, terima kasih Mbak Resti. Bapak Ibu mungkin izin yang bisa menyalakan kamera, bisa dibuka kameranya, kita akan foto bersama. Baik, saya mulai dari halaman pertama. 1, 2, 3. Oke. Selanjutnya halaman kedua. 1, 2. Ya. Selanjutnya halaman ketiga. Terakhir halaman keempat. Siap, sudah Mbak Resti, terima kasih.
Terima kasih kembali Bapak. Bapak Ibu sekalian, saya mengingatkan bahwa sebentar ada presensi. Mohon Bapak Ibu sekalian mengisi presensi di link tree. Nanti akan di-share oleh saya dan Pak Isamil. Dimohon untuk Bapak Ibu mengisi daftar hadir tersebut untuk mendapatkan sertifikat. Terima kasih. Acara selanjutnya, saya persilahkan Ibu Dr. Made Hesti Lestari Tata sebagai moderator untuk melanjutkan jalannya acara selanjutnya, Ibu.
Baik, terima kasih Ibu Resti. Saya akan berbicara dalam 2 bahasa, ini izinkan. Oke. Selamat pagi, very good morning Bapak, Ibu, ladies and gentlemen. It is an honor to me as a moderator in the webinar of the Expert Talk Series 1 of the Research Center for Ecology and Ethnobiology, BRIN. I think most of you have already knew that the nationally determined contribution, ONDC, and forest and other land use volunetsing have become an important national agenda. And our awareness on the importance of measuring and monitoring the above ground carbon stock in climate change mitigation has increased. However, currently the role of soil as below ground carbon stock is still lacking and somewhat neglected. Related to that issue, the Research Center for Ecology and Ethnobiology, BRIN, invited Professor Dr. Meine van Noordwijk to share his knowledge and give a lecture at the first series of the expert talk on soil as carbon store and sinks, expectation, patterns, processes, and prospect of transition, which has just published in the annual review of environment and resources, and first published online on September 5th, 2023. Let me introduce Pak Meine. It is what I usually call him since I knew him before he acted as my PhD co-promoter. Here is his CV. Please share the CV of Pak Meine in the monitor, Ibu Resti. Meine van Noordwijk was trained as a biologist or ecologist at the Utrecht University in the Netherlands. So actually he is my senior, and worked on plant roots in relation to soil fertility, combining models and methods in the PhD at Wageningen University. The below ground perspective brought him to agroforestry, and he joined ICRAF when it started a program in Indonesia 30 years ago. His research branched out from ecological to social and policy interests, as it linked farmer perspective to global policy issues. He currently a Distinguished Science Fellow at CIFOR ICRAF and Emeritus Professor of Agroforestry at Wageningen University. He already published many publications, and his citation number in Google Scholar has over 40,000 and in Scopus has over 13,000. I welcome Pak Meine to present your lecture. The video and audio has ended over to you, and the time for your presentation is 30 minutes. Please, Pak.
Okay, thank you. Let me share the screen, if that works. Okay, I hope this works. Come back. Yeah. So thank you, Pak Anang, thank you, Bu Resti for inviting me. Saya coba dalam bahasa campur, tetapi mungkin it's a bit slower if I try to translate it properly. And so, yeah, as Bu Resti said, the starting point for this presentation is a big review paper that is just published online, and that in that with a group of authors from Asia, from Australia, from Africa, from the Netherlands, from US, so from different continents, we set out to review the bigger questions that we have around soils as carbon. So clearly, as both Pak Anang and Bu Resti remarked, of course, soil carbon is now important in the policy debate. At the same time, there are still major challenges between the science and the details that we have about what data do we have about soils, and especially changes in soil carbon, and the expectations that we have within the policy domain. So yeah, our title is Soils as Carbon Stores and Sinks. So the long-term store and the sink as the process. It is about the expectations, and we can say in the policy domain, we go from a hope, the hope that something works, to a hype that everyone gets too excited about it. We go to a crash when people realize that the reality is more complex than we thought. And maybe after the hype and the crash, we can establish on the reality and have expectations that can actually match reality. So that's how we position this work. So it is reviewing the science. What do we know from the perspective of relevance? But I think there are many warning signs in this, that in the policy domain, it can easily be overstated, and we can easily create expectations beyond what we can actually find in the more detailed analysis. So that's the overall framing for for today. So in this review, I realized that, yeah, it is already 25 years ago, or when we first started in this work, I was working with Pa Kusumo Nugroho from that time the Pusle Tanak, and they had a large data set from the soil survey in Sumatra. And there was interest, the starting point of soil carbon in the tropical forest zone, a meeting in Nairobi. So I worked with Pa Nugroho on analyzing that data and then presenting it, and with a number of people working in Carlos Cherry from Brazil and Paul Woomer working on the African part, and Martel Barnou working on the carbon isotope part. We wrote together this paper. Okay. Now, at the same time, I think it's fair to say that after this paper, I was invited to become part of an IPCC panel in the second round of the IPCC that reviewed the global issues around soil carbon, and became part of the team that set up the methods for the IPCC, the National Accounting Scheme. And I think it's good to realize that the generic way that the IPCC suggests countries report on soil carbon is actually consistent with and to some extent informed by this analysis of Indonesian data. It recognizes that soil carbon at any soil depends, first of all, on how that soil would behave under natural vegetation. So the soil under forest, the same soil, the same location, the same climate, the same everything, but under natural forest, that would have a soil carbon content that is our reference level, the starting point. And then on top of that, we see that land use change will, in many cases, lead to a partial loss of carbon. So the carbon in plantation forestry tend to be a bit lower than that on the same soil without under natural forest, or the same under oil palm, or the same under upland crops, or when the land is abandoned under alang-alang. So we have a starting point is what that soil would be under natural forest, but then we realize it depends on the texture, on the clay and the silt. It depends on the pH. It depends on the elevation. Higher up in the mountains, it is cooler, and soil carbon tend to be higher. And as a secondary effect, we see the land cover effect. Now, this is basically the scheme that countries are asked to report on what is happening with their soil. So what is the baseline given the geography and the soil texture, etc. And on top of that, what is the relative change that we see linked with land cover data? Yeah. Now, in that paper, we found that in the 1930s, so that is now almost 100 years ago, 90 years ago, there was detailed data for the Lampung area published by Mr. Hardon, and they found a relationship between the pH of soils and the carbon, that is a curved form. We found that data from the 1930s still matches the data from the 1980s that was in the Pusle Tanak data set. And well, would be interesting to compare it with more recent data, but probably the pH effect is still so that the more acid the soil, so low pH soil, tend to have higher soil carbon. The soil carbon can be lowest between pH 5 and 6. And when we look to soils in the limestone domain, we might find some higher carbon again. So there is a complex relation which can be interpreted with bacteria versus fungi as dominating the soil system. So this is from 30 years ago, and this is sort of at the starting point of soil carbon in the global climate debate and the methods that have been developed from that. Now, a few years ago, we summarized a number of the data coming out of Indonesia soil data again, and we realized that there is a challenge with the parameters that we have for soil carbon stocks. Soil carbon stocks are calculated from the concentration of carbon per weight of soil and the bulk density, the compaction of the soil. And if we sample the 0 to 30 centimeters layer of soil and the soil gets compacted, we will see that actually more soil is, the weight of soil in 30 centimeters goes up when the soil gets compacted. The carbon concentration may go down, but in the end, we may find that the carbon stock, if we calculate, if we multiply concentration and bulk density, that the measured change in the soil carbon stock indicator is less than people would have expected, and probably less than the reality. Yeah? So the data on change in topsoil carbon probably underrepresent the real change because of that process of compaction. Now, it is possible to correct for that if you have, you know, enough about that type of soil, and you can separately understand the degree of compaction from the change in soil carbon, but it is not available at the national scale. When we summarize national data, it is that carbon stock as we have, and the change in bulk density is a bit of a problem, and that it is part of the change that we see in the overall data. Now, for that ARER paper, we start with a very interesting challenge that comes out of a recent publication for the Netherlands. Now, the Netherlands is a small country, and there is quite a good network of soil data points that are resampled every 10 years. Yeah, so for this paper, they had data from 1998 and a resampling 20 years later in 2018. And 1150 points, so quite a fair spread in the country, but it is the same locations that are resampled over time. And interestingly, the authors found that in the topsoil, the top 30 centimeter, the numbers are a bit lower than they were before, but given the standard error, given the uncertainty that we have, you have to accept the hypothesis that there is no change. Yeah? So the topsoil carbon in agricultural soils in the Netherlands has been zero change in carbon, has been carbon neutral, but the deeper layer of soil, the 30 to 100 centimeter, the data show a statistically clearly significant decline. Yeah, so overall, across the board, the soils, and these are classified as mineral soils in the Netherlands, have lost a considerable amount of carbon over this time period. Now, this is significant at multiple levels. First of all, in the international agreement, we focus on the data for the top 30 centimeter of soil with the argument that deeper carbon is more difficult to sample. Generally, there are less data. Generally, the variability is higher. And we expect the responses to be slower than for the topsoil. So people thought, okay, if we monitor 0 to 30, that's difficult enough in terms of data points. But if that is neutral, we may assume that the subsoil will be neutral as well. Now, this data shows that is not the case. And even when the topsoil is carbon neutral, we still actually lose a fair amount of carbon over this 20-year period. The second challenge is to understand what is going on here. What is the reason of this decrease, and can we understand it, and can we see whether anything could be done about it? Now, in this paper, the authors don't offer a full explanation, but a number of suggestions is, on one hand, yes, agricultural soils in the Netherlands are still, the drainage has increased, so soils are a bit drier now than they used to be. And that means that the subsoil is also drier, and we may have shifted some wetland soil to drier soils, and with that we get a decomposition of the soil carbon that there is. So it could be linked with deeper drainage. It could be linked that we've had warmer and drier summers. So we could say, well, it is because of the climate change that happened, the soil gets drier, and because of that we see more rapid. So if it's drainage, then it is due to human activity. If it is the consequence of climate change, then it is this, not the responsibility of the farmers in the Netherlands, but it is imposed on them. It is also possible that we say, actually, within agriculture, we still see a shift in crops. And in the past, half the crops would be wheat or barley or cereals that have a lot of roots and contribute a lot of deep soil carbon. And we've shifted to a larger fraction of sugar beet and potatoes that don't contribute much roots. So it could be the change in type of crops. And it could be, and that's the final argument, that in agriculture, with the selection of higher yielding crops and higher yielding crop varieties, we have crops that allocate more of their resources above ground and less below ground. And the below ground inputs now are from the same crops, within the same crop, are now less than they would have been before. Now, all these arguments can also apply in Indonesia, but we don't know. There is indication, for example, last week there was a meeting on cacao in Bali. There is indication that the commonly used cacao in Indonesia, farmers still has quite a lot of roots and has a lot of below ground part. But the improved cacao, the higher yielding cacao, has less root development than what we had before. With less roots, it potentially can have a higher yield if conditions are good, but it becomes more vulnerable to climate fluctuation, and it would contribute less to soil carbon in the long term. So it could well be that we have something like that going on within Indonesia, but we don't know. And in a way, this data for the Netherlands show that it is actually very difficult to make a clear statement at the level of a country. And again, the Netherlands is a very small country. The Brantas Basin, East Java, has the same number of people as all of the Netherlands, and Indonesia is much bigger than the Brantas region alone. So yes, even for a small country, it is very difficult to be clear about what happens with soil carbon. And it probably is a combination of land use practices, changes in water, changes in climate, and changes in the type of crops and the type of practices that together leads to this impact on the soil carbon. So a warning that it is not easy to be clear what happens. Now, for this review, we split up the overall questions. So we started with the expectations, and we want to know, on one hand, the theory of place. So how much variation is there in soil carbon across the globe, across climate, across vegetation zones? We want to understand the theory of change. So what how does land use change impact on soil carbon? And within that, yeah, we can try to go at the process level. What do we know about decomposition? What do we know about inputs? What do we know about the more detailed things in the soil? How do we have models that combine that with plant growth and what farmers are doing, water and how water is managed? And within that, is the net effect positive or negative if we combine that? So that is theory of change from a research perspective. Theory of change or theory-induced change from a policy perspective then comes in with, okay, what type of incentives would we need for farmers to change their practice? Could we increase soil carbon by doing things differently? And there has been a global effort sort of for ProMil, that the idea that we can increase soil carbon with incentive programs. Well, where are we on that? Is it really possible to induce the type of change that this Paris Agreement promised about soil carbon, or is it not? That is the bottom line question in the end. Yeah, so in the review, we tried to, within each of these questions, and we had authors who are experts in the different parts of this scheme, to see where are we, what do we know, what don't we know, and is this the high expectations that we currently see, are they justified, yes or no? And yeah, and I'm happy to refer people to the paper for the detail, but we can take you through the thing at an outline level. So the first part is this theory of place. Yeah, if we look at current maps of soil carbon, now this is a map only for the concentration in the top 5 centimeters, so the peat soils don't show up because they have very low bulk density, so they don't have a high carbon stock in the top 5 centimeters. They have a high stock if we calculate over the top 10 meters. Yeah. But basically, a soil carbon map for the topsoil shows that we find high carbon in the cold and the wet parts of the world, and we find very low carbon in the hot and the dry. And in the hot and wet, we are sort of intermediate. So Indonesia, we're intermediate. Some is in the light blue domain. In the African continent, the Sahara has very low carbon because there's nothing growing, there's no input. The Congo Basin is that same color as we find for Indonesia. And it is the overall, the dominant part is the climate. And within that, it is the counteraction of wetness and temperature that we find back here. Now, at the more detailed level, we have this Scorpon formula. So if you have a large data set, we can see how much can be attributed to the texture of the soil, to the climate, to the land cover, to the slope of the land, to the parent material, the time since cultivation, etc., etc. So there's this whole field of science of pedometrics that try to analyze these large data sets that we currently have. But for the global carbon accounting, the important thing is that a lot of that is given, the location and the parent material, etc., is the starting point. And for the policy part, we want to know, given that is the level, what does land use change do? So what is the variable part that comes with the age since cultivation and things like position relative to roads or rivers? Yeah, so there's a lot of detail. And the parts of the world that stand out in terms of carbon is the permafrost, the subarctic zone, the peatlands. And again, peatlands are, because the carbon is much deeper than most other soils. The mangroves, very small area, but quite high carbon stocks. And that's relevant for Indonesian context, the recent volcanic soils that can actually have a very high soil carbon concentration. Now, An important part here is that if you look at data are collected at many different scales, from the global to the landscape, to the plot, to the soil aggregate. And every scale leads to its own interpretation and its own conclusions about what are the dominant factors in the variation. And we can talk about the pedosphere, what is really the soil per se. And when we come to the landscape, then a lot of the things are more linked to the hydrosphere and how water is managed. That is an important part on soil carbon. And when we come to the global, then it is the atmospheric concerns over carbon and carbon emissions that start to dominate. But we see a range of, is it from the plants growing in the soil and the biota in the soil that are the actors? Is it the farmer who is the actor? Is it the landscape manager? Is it the policy, the government that set government policies? Or is it the global community that decides on rules for climate policy? And the interesting thing is that indeed you need to understand the full scale of things. You need to go from the details in the soil particle up to the global policy to fully understand where we currently are. Yeah. So, but empirical studies, some will say, texture is the most important part of soil carbon. Other people will say, no, it is about climate, it's about other properties. Somebody may need to close their microphone. Yeah, so in the paper, we try to describe the different types of science, different types of evidence that we see coming linked with scale. Now, another part, and that is more toward the policy, is that, we can look from the individual, from the farmer or the consumer, and the choices they make on one hand. On the other hand, we have the global commitments for climate change, and we have then the national, the NDC, etc. So we can look at it at the scale of data, at the scale of feedbacks of processes, at the scale of rules and institutions, and at the scale of goals. Now, one approach is that we start from the goals, and we start with the NDC and the NAMA and the RED+, and we work down from there towards the lower end, what actually happens on the ground, and that's sort of following the policy trail. And then we go bottom up, we go from what happens on the ground towards the more global synthesis. Now, most of the technical data starts from the plot scale, the farmer, and tries to work its way up towards the national scale. Most of the policy starts from the national scale and tries to work their way down. And it is challenging for these two approaches to meet in the middle. Yeah. And a lot of the more detailed analysis of how soil carbon will change is not yet reflected in the national accounting. So people can maybe increase carbon, but if it's not picked up in the national accounting scheme, then we will not be able to represent it at the international level. So there are some major challenges still in this cross-scale thing. In the third part of it, we have this, many of you may have heard of the forest transition theory that, okay, we started with forest and forest got lost and we opened up land, and then there is some recovery. Trees are coming back in the landscapes. Even in cities, we may find trees are actually quite useful, and we have trees in the cities. Now, something similar has been noted for soil carbon, that there is a phase, for example, data for upland soils in Java. Yeah, we saw a considerable decline of soil carbon in Java in the 1950s, 1960s. But from the mid-60s on, we actually see a recovery of soil carbon, partly because of the interest in soil conservation and erosion control measures, but according to the people who have analyzed in detail, also because of the change in agricultural practices. When we go from one crop of rice per year to 2 crops of rice per year, we actually increase the wetness of the site. We increase the root inputs to the site. And what we see is that the soil carbon is actually increasing, not to the level that it was under natural forest, but quite a bit higher than in the lowest phase. Now, that soil carbon transition that was first noted for Java, it has since been documented also for China, also for Korea, a number of places in Asia, mostly with rice-based economy far, and that's often the most intensive data come from that part. It has also been seen in some European and some North American side. So yes, the dominant story is about the degradation of soil carbon, but it is possible to bend the curve. It is possible to go into a recovery phase, and there is evidence that that is happening at relevant scales in at least some of our countries. In a scope review, we try to review what do we know about soil carbon transition for different countries in Asia, Africa, and the Americas. And the idea is yeah, since then gradually been picked up. So the idea that we can be carbon neutral in the soil is, first of all, that we can stop the decline. It is possible under certain conditions to expect a recovery, but at the country scale, you'll probably have still places that are declining. You have some places that are recovering, and you'll be happy if overall you could claim that neutrality is what's the result that we have. Yeah. So if we analyze that a bit further, then yeah, a very simple equation is that the stock is in equilibrium. The stock is able to equal to the input times the mean residence time. The mean residence time we measure in years. The input we measure in ton of carbon per hectare per year. So if we multiply with the years, we end up with a ton of carbon per hectare. Now, in that, we see that the soil carbon consists of different pools. There is part with a high turnover, a short residence time. There's stuff with a very slow response, so maybe a small input, but a long residence time. And we need to understand how these different fractions interact in existing models of carbon. If we look at the more complex version of it, we see that the soil carbon in the center of the curve here is a matter of input. So what is the organic input coming into the soil as surface litter, as root turnover? What are the animals that chew up the carbon? What are the bacteria that decompose it? What are the fungi that decompose it? So what is happening at that detailed process level? And how is that related to climate? How is that related to what farmers do? And how is it related with the soil biota that we have? That's a big chunk of work. And even this one is already challenging because the vegetation ecologist will see the above ground part, the soil people will see the earthworms and the termites, the climate people will measure the climate, and the farmers will, and it's already challenging enough to bring all these things together. In doing that work and linking it with the models that we currently have, there's a very strong conclusion that the deeper soil carbon is mostly based on roots and root input and mycorrhiza. Yeah, whereas most of the management of soil carbon is about surface litter and about organic inputs and biochar or anything that you add to the surface. But in reality, most of the change in the deeper soil layers is based on roots and based on the below ground input. And we still have very few data about it. So there's a lot of people studying litter decomposition. There's very few people with real data about the below ground input. And that's still, yeah, a priority for the underlying research to get closer to that part. Bo Hesti has worked on mycorrhiza, so you're a part of it, but we still need more of that type of work to connect with the soil carbon. Yeah, so in the paper, we try to review what is known at this level and what can we say. In the models, the effect of soil texture is because, we can get a fairly close association between carbon and mineral parts in pools with a long residence time, to fairly stable carbon is in that part. And that's where we think like this effect of the volcanic ash comes into that the aluminum, free aluminum in the ash bounds with carbon, and that those are stable parts. So that's where things come in. Now, for Indonesia, we've got the very specific challenge at the same time, the opportunity of active volcanoes with a lot of volcanic ash that comes with 0% carbon when it comes out of the volcano. And when it is a matured andosol, it will have 10% C, so there's a very considerable carbon sink in volcanic ash. But in the short term, the ash is very disturbing and destroying vegetation, and there's a part where there's a important, but specifically for Indonesia with all the active volcanoes, that's a topic of research here in Indonesia that is relevant overall. That links us to the next step of challenges is the erosion sedimentation. Now, if you work at a plot scale, then a lot of carbon gets lost if the topsoil is eroding. At the landscape scale, however, that is not the case. If we look at the Brantas Valley, all the fertile soils where all the rice is grown is all erosion from the mountains. It's all because of the material that comes from the volcanoes that gets deposited in the valleys, that we have soils with a good carbon content that are fertile and where we grow the rice, etc. But without erosion, these soils would not be there. So the challenge is that it's easy to measure erosion as a loss, but at the landscape scale, it is equally a process of gain. And the technical literature varies on that. Some studies suggest that erosion actually has a net positive effect on soil carbon, that the loss at the places that are eroded is more than compensated by the longer residence time of carbon in the deposition part. It's also complex that a lot of the mangrove soils, the carbon in mangrove soils is not coming from the mangrove trees, but it is river sediment with carbon and sediment that gets deposited in the mangrove. And without mangrove, it would not be in the atmosphere, it would be somewhere else in the ocean. So it is in the mangrove, but we cannot say that it is sequestered because of the mangrove. It is part of a broader flux. So those are real challenges at the policy, at the accounting level, that just knowing how things change at one part of the landscape doesn't really tell you the net change in the broader system. Now, then we look at the effects, the interactions with plant growth and the stories of mixed systems of agroforestry practices, tree crops on that front. And there we see, I was recently in Bali, Westi, and it is interesting to think about agroforestry and the GWK. I mean, the plan for the GWK was a nice integrated statue with Lord Shiva and the Garuda, but in practice they are still separated out because I think the statue of the Shiva was too heavy to be carried by the Garuda. So in theory, we think agroforestry is a good way of practicing, but in practice we still have forestry on one hand and agriculture on the other side. It is challenging to integrate the two. So even if those mixed systems would have good opportunities in terms of soil carbon, we still have policy domains that are either about forestry or about agriculture, and that not yet look at the combined systems. Now, on the adaptation side, we do see that higher soil carbon does help a bit in the buffering, not as much as people think, but okay. With higher soil carbon, you may tolerate another week of drought. Yes? So with low soil carbon, maybe after 2 weeks without rain, your crops start to wither. If they have more carbon, they can survive for 3 weeks or 4 weeks. It doesn't really help in a very long dry season, but it does help a bit. So yes, there is a benefit in buffering of maintaining higher carbon, but it is smaller than many people think that it is. Now, this is a more technical detailed part, but it does show that the maintaining soil carbon at, let's say, 2% C can be based on the below ground turnover, the root turnover, as well as the litter layer. You need a bit of both, but the root turnover can be an important contribution to maintaining soil carbon. And once again, that is something that we don't have a lot of data about to support it in detail. Now, when it then comes to the bioeconomic, so the theory of induced change, so would changes in policy help? Would it induce farmers to do things? Yeah, I think when we talk about agroforestry versus agriculture without trees, then the tree component can add substantial deeper root turnover, deep part on that. Within cropping systems alone, yeah, I think the opportunities are there, but quite limited. So it's interesting to see that the soil carbon transition that we have observed was not based on carbon incentives, but based on farmer choices of land use that matches their knowledge and their rights and the markets. And it had so far carbon stock as a consequence, so not because of policy, but because of overall agricultural practices moving there. The idea that agroforestry or mixing trees with crops is a positive thing can help put in the right direction, but farmers would never do it because of carbon. It can have positive effects on carbon as a side effect, and I think we need to put that in the broader perspective of how do we understand land use and the choices that people make. Now, a special story is, of course, in Indonesia, is about the peat and the peatlands and the tug of war between people who want to drain the peat and people who want to re-wet the peat. And that's, again, that would not be settled by carbon per se. Of course, at the policy level, it is the risk of fire and the human health problems of that are at least as relevant for policy as changes in carbon alone would be. So our view on that 4 promille is mixed. We do see a number of things can work in the right direction, but the target of 4 promille is probably too high to be realistic in many countries. And the important thing is to at least become neutral, at least to stop ongoing degradation. It is possible for, with our peatlands to actually stop ongoing degradation. That's a big thing. On the mangrove side, yes, maintaining that would have many other benefits and the carbon would come along. On the volcanic ash, we have some real opportunity to quantify that. Yeah, so there is things that can be done on that front. But overall, our story is that, we need to understand the theory of place, that every part of Indonesia has its own story in terms of background soil carbon, that in terms of the theory of change, the effects of land use, it is the combination of things that change the residence time, that drain and that make things faster in terms of decomposition, the changes in inputs, especially those below ground, that we need to understand, and then the theory of induced change at the policy level. And be careful not to raise expectations too high. These are then reflected in the summary points and the future issues that come around that. Now, this is a global review, but I would think that for Indonesia, it is indeed relevant, and it's need to recognize Indonesia. We both have volcanoes and peatland and mangrove, and we have many different ecosystems. The net emission for Indonesia as a whole is the sum of all these different parts. If Indonesia wants to become carbon neutral in terms of soil carbon change, that's a nice target, but it requires a lot of detailed data collection to check whether that is actually happening or not. And like in the Netherlands, there can easily be surprises that things are not going in the direction that the policy wants them to go. And that's a challenge for any government anywhere. But yeah, also in Indonesia, once you have environmental targets, then it is difficult for people to accept that reality does not follow the plans that people make. And it is our role as scientists to help, to be honest on that, and to fully understand what is happening, and not be driven by policies that, because we plan to have it positive, it should be positive. No, maybe the data show differently, and we need to deal with that. Wesley, I'll leave it like here. I'll be happy to respond to any questions. Maaf, in the end, I talked English only, I think, but I hope it was clear. I'm happy for the questions to be in Bahasa Indonesia. I'll try to respond in that language. Thank you.
Okay, thank you very much, Pak Meine, for the insightful lecture and knowledge. And I believe the participant has already had a question in their minds. And now we have some time for discussions. And I'll give opportunity for the participant to ask question to Pak Meine in Bahasa Indonesia. As Pak Meine said, it is also okay, and Pak Meine will try to answer in Bahasa Indonesia as well. Anyone of you will ask in directly to Pak Meine? In chat, I saw here one question from Pak Deki. Would you ask directly to Pak Meine, Pak Deki?
Apologize, I'm still in traffic. Would you mind just read the question from the chat? Thank you.
Okay. Yeah. Thank you, Pak Deki. Yeah, here Pak Deki asks about I would like to have your opinion, how significant it is, soil carbon as a consideration for sustainable soil management, for agricultural or forestry production in Indonesia, and what about soil nitrogen or other soil nutrient? Thank you.
Yeah, okay. Well, clearly, the interaction between soil carbon and nitrogen is important, and of course, in terms of greenhouse gases, it is the CO2, the carbon, the methane, and the nitrous oxide are the 3 points of consideration. And at the same time, it is, of course, especially on the methane part, we see that wetter soils that would potentially store more carbon would also emit more methane, which is a more dangerous greenhouse gas than the CO2 would be. So if we not only look at CO2, but look at both methane and CO2, then even the re-wetting the peat is not as simple as people would think it is. In many cases, at the same time, there is a negative association between nitrous oxide emissions and methane. So systems with a lot of methane emissions would not emit nitrous oxide, and vice versa. So yeah, the net emission across the 3 greenhouse gases is a bit more complex than only looking at soil carbon as a whole. It depends then a bit on what type of soil we talk about. And in the rice soils, for example, we have the concerns of methane and N2O are dominate over changes in soil carbon. In the peat soils, it is still the net change in carbon is the more important part on that. So yes, at the more detailed level, we do need to go look at nitrogen, nitrous oxide, methane, and changes in soil carbon together. On the positive side, we know that higher soil carbon can increase the water retention in soil a bit, and that work that maybe you can tolerate another week of drought in a soil with more carbon than in a soil with lower carbon. So yes, it helps a bit. It pushes in the right direction in terms of climate adaptation, but it is not, it's not dramatic. It is not a huge change. So it's important to maintain it, but don't create too high expectations about it. And overall, I would say, in agriculture, forestry, having more trees in the system would generally lead to higher, especially deep soil carbon, which is a relevant thing to do. But as we said, I mean, the ongoing selection in carbon in cacao or coffee may be towards lower root contributions in the longer term. And we don't know enough about that for many of the other tree crops and the plantation forestry. A big review that Bohesti and many colleagues have been worked on show that, of course, in forestry, plantation forestry operates at lower soil carbon than natural forest. And we can try to understand the processes that lead to that. Let me stop there. Yeah.
Thank you very much, Pak Minas.
Okay, yes, thank you, Pak Mena and Pak Diki. Here is, we see Ibu Siti Sundari raise hand. Yes.
Terima kasih Bu Hesti. Selamat pagi Pak Mina. Tadi saya, maaf, I'm interested in your explanation about the effect of water cycle and then also as soil organic carbon, and then how is the mechanism between the water cycle, including water balance, and then the leaching organics. I mean leaching organic carbon in the and then the input of external organic. So
okay,
how can you? I mean the explanation of the effect of water cycle.
Okay, well, there are 2 points that on one hand, of course, under very dry conditions, soil biota stop, they don't work. So in a very dry soil, carbon is conserved, but there's not much activity. If the soil get wetter, we get and get re-wetted after drought, we see a flush of microbial activity and in the short term, high CO2 emissions, at the same time, more nutrient mineralization and more activity by root. So things are cleaning up. If the soil gets very wet, then most of the microbial activity slows down and the residence time go up. So under wetland conditions, whether it is a marsh or even a peatland, of course, decomposition is slower than under aerated conditions. So on the very wet hand side, anything that makes things drier would speed up the decomposition and lower the carbon stock.
Okay, thank you.
If you look at the transport, then deeper carbon, most of it comes from roots and mycorrhiza, but there is also leaching of organic molecules. And the aerhitam of the peat is organics that leach out of the system. But how much that contributes to deeper carbon is still debated at a more detailed level.
Yeah, okay, thank you, Pak Mina. Makasih, Ibu Hesti.
Ya, sama-sama Ibu. There are also some question on the chat. Like Pak Agus Tampu Bolon, would you like to ask Pak Mina directly, Pak Agus? Hello.
Thank you, Dr. Hesti. Thank you, Prof. I have some queries about the soil organic carbon issues, especially in Indonesia. I think there are two distinct management of soil organic carbon, one in dryland ecosystem and one in wetland ecosystem. I believe that for in dryland ecosystem is very important for agriculture production system, but in wetland like a mangrove, because of around 85% of carbon stored in the below ground, especially soil deposition. Only 15% as above ground biomass. The important things are that what are the policy and management context of soil organic carbon conservation in order to promote in this year of things and food to food security and to promote food security in dryland, and especially for in the second questions about the is there any what are the direct drivers of soil organic carbon loss in Indonesia? Do you have any or not only direct drivers but also underlying drivers? And this is very important as a step to formulate the policy and management I think context or management implication. That's my question, Prof. I think it's very important that soil, but let's recognize soil organic carbon in calculating what do you call it, carbon, carbon sequestration or carbon sink or carbon loss emission in global context. We are focused on above ground biomass from forestry sector, not below ground like rhizosphere and also soil organic carbon. Thank you, Prof. Thank you for explanation.
Yeah. Okay. Well, and to the current national accounting system would attribute changes in soil carbon to land use change. So if we go from natural forest to plantation forestry, or we go from plantation forestry to food crops, or we go to food crops to tree crops, each category would have its own typical carbon CCRF ratio. So a change in land use between categories is reflected in calculated carbon storage or carbon emissions, but not within, let's say, within a system. It's supposed to be in equilibrium. Now, that is not true in the sense that of course we've had a lot of concern about degradation of upland soils, and since the 1960s we had the big debate about upland soils are degrading and they're losing their carbon, and at the same time a lot of the efforts that people took about erosion control and increasing infiltration and reducing that have been very helpful and probably the basis of this measured soil carbon transition. So upland soils on Java now are probably in a better shape than they were 30 years ago, as a consequence of better soil management and more permanent cover, etc. At that point, of course, the litter layer is very important as protecting the soil from erosion, and any permanent tree cover that leads to litter would protect the soil, etc. Same time, it is not clear how much from that litter would enter the deeper soil layers, and yeah, we don't have, well, we have some data about the topsoil, but we definitely don't have enough data about the deeper soil layers to be clear on that. At the scale of national accounting, I think we should have data about what happens in deeper soil as well as upper soil. At the same time, not at the level of individual farmers. So there's a lot of ideas in carbon farming that individual farmers would measure their carbon and then get credits if they can show after 5 years that it has increased a bit. We're quite skeptical about that. But at the level of overall what happens in, well, the data that we have, for example, for oil palm suggests that oil palm in topsoil carbon can be carbon neutral. There would be a degradation in the early phase of the oil palm, and the later parts it would catch up with it. So if you calculate it over the whole rotation, it might be carbon neutral under good management. At the same time, not all oil palm plantations have matched that target, and some have a net degradation. So at that scale of within any crop, in coffee, we see there's type of coffee with good litter layer and good protection, and the type of coffee that still has a lot of erosion. So within that, but then it's basically, good management practice in terms of surface processes will probably help on the soil carbon as well. But the deeper layer, we don't often know enough about it. At the landscape scale, at the same time, of course, erosion is not necessarily leads to loss of carbon to the atmosphere. In the mangrove, a lot of the mangrove carbon does not come from mangrove, but comes from the river, is captured in the mangrove out of other systems. Without that mangrove, it would not necessarily end up in the atmosphere. It might end up somewhere else in the ocean. Complicated things for the carbon accounting sphere. But we need to be clear on that. And I've been discussing that with Daniel Moriaso many times over. There is this challenge in mangrove systems to really understand the larger geological fluxes between land and mangrove and ocean. And that is not as simple as the policy scheme would deal. And there is always this question: what is anthropogenic change, and what is the response of systems to ongoing change, etc., etc. So, as a scientist, it is more complex. At the policy level, we use a more simplified schematic. But that interface, we need to appreciate the need to fully understand all the processes, as well as the relevance for policymaker to simplify. Sorry, that's not very clear, but I think we have there is a challenge out there between the full understanding and what we can portray in the policy sphere.
Thank you, Prof. Thank you, Prof. So can I conclude that the soil erosion control and good management practice of soil surface in production agriculture production system is the management prescription for conserving soil organic carbon? Is just a simple, or for the wetland, like promoting polyculture is a way to conserve soil organic carbon, something like that, Prof?
Yes, I think at the simple level, the surface litter layer, and if we maintain infiltration and we maintain surface litter, has many positive effects on the agricultural system and is part of good practice anyway. So yes, that helps with soil carbon. At the same time, sort of carbon neutrality is the first target. Let's say stop degradation, and make sure that we do maintain that neutrality. Some valid concerns about the deeper soil carbon are there, but again, not at the level of individual farms, but at the level of national accounting. This is continuous debate whether 0 to 30 carbon, maybe about half of the carbon in the top meter, should we go for accounting for the deeper soil carbon as well? my own sense is that it has a high cost in terms of a lot more. We need a lot more data than we currently have, and it probably will not. It will not be easy to claim positive effects on the deeper. So and it can easily lead to surprises like this Dutch data set shows. So yes, as a scientist, we need to keep an eye on it. But at the policy level, let's be happy. Let's be happy that we can show carbon neutrality for the soil, and not claim increases at an overall scale. I think that's probably the wise line at this point in time.
Thank you, Prof, for your response.
Okay, thank you, Pak Mina. So next question is from Pak Fakih. Pak Sugeng, tunggu sebentar ya Pak. Ini ada yang dari chat room. Pak Fakih menulis bertanya dalam bahasa Indonesia. Apakah mau langsung bertanya dengan Pak Mina, Pak Fakih?
Ya.
Silakan. Silakan Pak Fakih. Bapak mau langsung bertanya atau mau saya bacakan pertanyaannya? Oh baik ya, saya bacakan saja kalau begitu. Pak Fakih bertanya, Pak Mena, bagaimana cara-cara yang efektif dalam pencapaian target penurunan emisi gas rumah kaca di Indonesia, mengingat jumlah penduduk yang terus bertambah dan berkurangnya luas hutan di Indonesia.
Oke. Ya, saya pikir ini, ya kalau target itu carbon neutrality itu tidak ada masalah antara produktivitas dan carbon neutrality, ya. Yang masalah ada dengan degrading practices, tapi yang intensifikasi untuk produktivitas biasanya ada dampak positif ke soil carbon juga. So saya pikir tidak ada konflik antara targets tentang soil carbon dan targets tentang produktivitas tanah dan food security dan semua. Yang dari perspektif agroforestry memang ada produktivitas yang secure dan soil carbon, dampak positif ke soil carbon. So saya pikir tidak ada trade-off antara food security dan carbon neutrality di skala Indonesia. Ya.
Jadi maaf Pak Fakih, apakah masih mengikuti? Tidak ada respon. Oh masih, baik ya. Ada pertanyaan lanjutan Bapak? Atau sudah clear? Baik, terima kasih Pak Fakih. Ya. Oke, kalau begitu, ya sama-sama. Terima kasih Pak Fakih. Kalau begitu, next question is from Pak Sugeng Budi Harta. Nanti setelah itu Pak Aris Sudono. Silakan Pak Sugeng. Silakan Pak. Pak Sugeng masih mute, Pak. Pak Sugeng, jadi bertanya, Pak? Masih mute tapi. Ya?
Can you hear me?
Ya, ya. Silakan Pak.
Ya, selamat siang Pak Meine. Thank you for the opportunity to
ask the question. So basically, my question, some of my question is already answered by Pak Meine regarding the feasibility and cost of how we monitor and measure the carbon in the soil, especially the subsoil. So, or in the context of a policy, it's quite difficult to implement if we don't have a more simpler or straightforward method or a framework to measure the soil organic carbon. Even for the more easier carbon, such as the above ground, we still debated on this issue. So, how you think that is there any you do for as a research organization? What thing to do to make it policy relevant issue to measure soil organic carbon that can be used in a policy level? And also that's one question. And the second question, actually, a more fundamental regarding how is the proportion of subsoil organic content in the whole carbon. So, for example, if maybe it's not much or not as high as topsoil, for example, let's say 5%, maybe we don't think that it's quite relevant or quite important to put it as a NDC aspect as well. So okay, that's the question that I asked. Thank you, Pak Meine.
Yeah, thank you, Pak Sugeng. Well, maybe to start at the end. So, from the data that we have for Indonesia, we have the general relationship between soil depth and carbon is an exponential function, and it works out such that 0 to 30 is about half of the total in 0 to 100. So there's about as much soil carbon in the layer between 30 centimeters and 1 meter as there is between 0 and 30. So 50-50 is easy to remember number on that front, and it is about right. So from that perspective, yes, if we say we account for 0.30 and there would be about as much carbon in the top meter. Now, on some soils, of course, there's also there may be soil carbon up to 3 meters depth, and others more shallow than that. It doesn't stop at 1 meter either. But for the debate, I think the debate is about going from 30 to 1 meter, and yeah, the total stocks would be about double if we account for that. But our ability to recognize changes in that is significantly lower, and it becomes more difficult to have the evidence that it is stable. I think in terms of the more fundamental understanding, I mean, if we do follow this line that actually it is the root input that matters, we have relatively simple methods to describe trees in terms of are they shallowly rooted, so are they contributing to the topsoil, or are they deeper rooted and contributing to the deeper? We've actually applied that to studies of erosion and landslide control. And in landslide, you need both types. You need trees that hold the topsoil together, as well as you need trees that are anchoring and are deeper rooted. So there is, from the data, a clear advantage for mixed systems where we have some trees contributing topsoil stability and others contributing to pinning the whole vegetation to the soil. And I think we can take that forward into the soil carbon domain, and it would be possible and from other perspectives relevant to collect that type of data about the dominant trees that we have in our various systems. That's something that is doable, and I think we can relate that to the process in the longer term of can we expect subsoil to be stable or not. If we only have shallow-rooted trees, fast-growing shallow-rooted trees, then we can be quite sure that our subsoil will be declining over time. If we do have enough trees with deeper root systems in the vegetation, then it's reasonable to assume that we can maintain neutrality of deep soil carbon. So I would go there for, it's more precise than just saying land cover. It's one step into what type of trees do we have, but it is then possible, I think, to make these type of links and be on the safe side. Again, it is a no regret option because in terms of slope stability, it is also what you want, and in terms of prevention of landslides on sloping land, etc. So I think that at that scale, there are things that are doable and that would be relevant and that haven't yet been done. So those would be on my list of suggestions of what type of research could be done and could contribute to this in the longer term. Thank you.
Okay, thank you,
Thank you.
Another question?
Very clear.
Okay.
Terima kasih.
Yeah. Terima kasih Pak Mena, Pak Sugeng. The next question is from Pak Aris Sudomo. Would you like to ask Pak Mena directly, Pak Aris?
Okay, makasih Bu Esti. Yeah, I try to ask to Pak Meine. Thank you, Pak Meine. I am conducting agroforestry research in Ciamis because before I was research in Ciamis. So now I am at Brin and I still do agroforestry research in Ciamis. I have some question. As we know, in community forest, there are some planting pattern by smallholder. For example, border trees, make planting, and alley cropping maybe. So, if the objective of the research is we want to know about the carbon sequestration between planting pattern. So is it enough or is it sufficient to measure vegetation biomass atau above ground biomass without soil carbon in underground? Is it enough? Maybe if you are reviewer to paper, so if we just measure above ground biomass, is it enough? Thank you.
Well, in the IPCC recommendations that carbon accounting involves 5 pools, and of course the 2 biggest pools are the soil and the above ground biomass, and that is followed by the root, so the below ground biomass, by the surface necromass, and then the dead wood category. So by and large, of course, the most dynamic is the above ground biomass, and by and large we assume a shoot-root ratio of 4:1 or something like that. And we're not going to measure the roots all the time. And whenever we actually went into the detail of checking out, that 4:1 ratio is pretty good, and you have to take a lot of effort to come up with anything better than that. In that overall domain, yes, it's reasonable to assume that soil carbon will be maintained over time. Yeah. At the same time, we recently did some work in West Sumatra with project that tried to get restoration, to get agroforestry going in Imperata grasslands or systems dominated by ferns and Imperata. And then, yes, if we're honest, in the first 1 or 2 years of that conversion, we see a decline of soil carbon because the Imperata actually maintains pretty high soil carbon. Grassland, unless they are burned 3 times per year. But if they are not burned, then actually there's not much wrong with the soil under alang-alang. And a lot of the conversion to agroforestry, you would have to count on the first couple of years. You may actually see a decline before the new system brings in new types of carbon. So the standard at the project scale is to assume that you have neutrality for the soil. Well, if we think of a 10-year time frame, that's probably okay. But don't be surprised if in the beginning of an agroforestry conversion, you actually see lower levels than you had under the Imperata cover. So yes, and of course, in the detail of your agroforestry and between the border and the center of the plot, etc., there probably are all sorts of detailed patterns that take a lot of effort to describe properly. And by and large, I would say take a especially mixed system and check that neutrality is an acceptable assumption. But yeah, do recognize that soil carbon transition, the declining and the recovery happens over time in any plantation crop. It happens within the zone system, that under the tree it will be a bit higher and away from the tree it will be a bit lower. So there's all sorts of complexities out there. But the time average carbon stock, assessing things over the life cycle of the system is relevant for the accounting. And that can take care of a lot of detail that otherwise will spend a lot of time in measuring all the detail, and still we see that there are negative phases and positive phases, and they can cancel out. So yes, focus on the above ground as the more immediate change, but do check that neutrality is an acceptable assumption, I would say.
Okay, thank you. Thank you, Pak Mina. Okay. Maybe if I have if I have a question again, maybe I will contact you, or I will contact with Bu Hesti maybe. Thank you.
Silakan.
Yeah.
Thank you, Pak Mina and Pak Aris. Any other question from the audience? Raise your hand as we still have some time. From chat room, we didn't see some question.
Ya, kalau masih ada bisa ditanya.
Ya, kalau masih ada pertanyaan, silakan. Kita masih buka sampai 11.45. Kalau masih ada yang mau bertanya.
Jadi istilahnya betul-betul membantu gitu.
Maaf, ada yang belum. Bisa raise hand langsung. Atau mungkin sudah cukup? Ya. Baik, ya. Mungkin sudah cukup, mungkin ya. Baik, mungkin boleh saya bertanya kepada Pak Mina?
Boleh.
Ya, ini pertanyaan general saja, Bapak. Mungkin tadi sebetulnya sudah ditanya oleh Pak Sugeng, tetapi mungkin saya perlu rekomendasi dari Pak Mina. Kami di PRE terutama, kira-kira apa saran Pak Mina untuk riset?
Muted? Sorry.
Yeah.
No, I missed the last bit.
Yeah. I asked, what is your recommendation for us research as a researcher in PRE or BRIN? What research that we can do or related with soil organic carbon. Yeah, not only the soil organic carbon, but also other type of soil like nitrogen and the others. Thank you, Pak.
Yeah. Well, I think one of the sort of unique or opportunities that we have in Indonesia more than in many other countries is, of course, the whole volcanic activity and what happens with volcanic ash, and how is that? Yeah, what is the chemical weathering, but how does that interact with the vegetation? We have this interesting nitrogen fixing trees, the parasponia, on the volcanic ash, and that has both relevance towards the disaster response of, right? So a lot of that volcanic ash is very mobile in the landscape and is causing a lot of problems downstream if it is not captured within the landscape. And at the same time, we see, and yeah, there's been some study in the Gunung Kelut area that the mother trees of parasponia that are important for the recovery are not yet identified and not yet recognized, and the current disaster response for volcanic eruption does not seem to be fully up to date with current understanding of that. So that's a topic where some more basic understanding can have spin-offs both towards the disaster preparedness stuff, as well as documenting that, yeah, considerable carbon sequestration that happens when volcanic ash becomes an aerosol from zero to 10% C, and what happens within that. Now, at a more detailed level, one of the PhD students who defended his thesis next month in Wageningen looked at this hydrophobicity. So the volcanic ash with organic matter is actually water repellent, and infiltration is problematic on that. And so there's, on the short term, negative effects of organic matter on the soil physical conditions that are opposite from the long-term positive effects. So there's stuff there that can be further analyzed and further, and I think it would be relevant. Yeah, the spin-offs is towards the disaster preparedness and things in that domain. I would say for the more regular, yeah, of course, things like, well, oil palm plantations, from the work that Ikraf and the colleagues did so far, we think it is or can be carbon neutral, but in other tree crops, in coffee and cacao, I think at the moment, the movement towards lower root development would be a risk for that. So working with coffee, cacao systems and checking the relation between yield improvement and below ground processes is beyond what people in Jember from the coffee, from the productivity side would do, but there is good ecological work to be done on that front. And within that, yeah, making this link with rooting patterns, this link with mycorrhiza, this link with the soil biological part and the consequences for carbon. I think, yeah, there's important, a bit more fundamental stuff on that can help us to make choices at the more policy level on what to include, what not to. Yeah. Overall, I think it is the life cycle for those systems. We want to do a life cycle assessment. So we want to scale up to the whole rotation length. And increasingly with all the replanting, we want to see what happens when you go from one rotation to the next. And generally there is not much data on that and not much things on that. I would say there are still relevant things out there. And then, yeah, toward the forestry side, it is that switch from mixed, diverse natural forest to plantation forestry, where we have reason for reasonable concerns that your soil carbon is not maintained. And it may depend on the type of trees that are used in the plantations, and where a more mixed, diversified system could probably be positive. So I think that there is space for in those things to do a bit more fundamental work to back up the more applied accounting. At the same time, and that is to all the colleagues who are on the accounting, the national accounting systems are, of course, very simplified. And we use pretty crude categories for activity data. And we need to move to a bit more sophisticated systems over time. But there is this trade-off between data requirements of very detailed classification and the opportunity to have a more accurate accounting there. But it tends to be that at the process level, people have so many reasons why there's so many different things and everything has some impact. And at the accounting level, we take a very simplistic view, forest, non-forest, or forest agriculture. And we don't have space for all this more. So I think, we need a more balancing approach between the more detailed accounting because there are real differences that we see on the ground versus what can be handled at the national level in terms of data availability. So that top down versus bottom up, we need continued dialogue on that, and in between we have sort of regional case studies where you can show that more detailed things better. That can over time inform what would be picked up in the national accounting system. Those would be from the technical to the policy things that I think where relevant work can be done.
Yeah, thank you very much for so many ideas actually. There are still some gap on the practical thing from the fundamental science of carbon carbon assessment to the national policy on the carbon accounting. Still we need to develop and also engage with the policymakers on this. So there are still some questions. Are there any question more in the chat room? No, I don't. No, I didn't see. Okay, I think this is all for the expert talk today, and I thank you very much for Pak Meine for sharing your knowledge and expertise, and also for the audience for active participation on the discussion. And I hand over the time for the Master of Ceremony to Ibu Resti Ura for the next agenda. Thank you.
Thank you, Bu Hesti dan Prof. Meine. Terima kasih. Materinya sangat menarik ya untuk kita simak bersama Bapak Ibu. Acara selanjutnya, the next agenda, the next event is awarding of certificate and souvenir to Prof. Meine as speaker. The certificate will be handed over by Dr. Anang as the head of Research Center for Ecology and Ethnobiology, as well as closing the first expert talk series today. Dr. Anang. Okay.
Thank you very much, Dr. Meine. Is it clear from here? Oh, okay. So after almost 2 hours, Dr. Meine, and I'm so thankful, grateful for the presentation and also the discussion. It's really, I think, very useful for us, especially related with the soil carbon and also how we maybe how we have to do based on research and innovations to support the national commitment, especially Dan tadi juga sudah ada pertanyaan dari rekan-rekan dari Pustanpi dan mudah-mudahan sangat bermanfaat. Dan untuk teknisnya bagaimana nih Bu Resti? Jadi Pak Main, to appreciate today, there will be a certificate, and I am very happy to thank to the presentation, and yeah, maybe just the certificate, but not really but I think the moment and the knowledge that you share and the science that we've been discussed, I think that's the most important that we can learn together. I think begitu ya Bu Resti, saya serahkan sertifikatnya untuk Dr. Main, dan terima kasih juga Bu Hesti untuk memoderasi, dan mudah-mudahan expert talk ini bukan yang pertama dan bukan juga yang terakhir, tapi mudah-mudahan ini sebagai awal yang baik untuk kita bersama-sama belajar untuk kita lebih tahu ke depannya. Demikian Bu Resti, dan sekaligus resmi ditutup ya acara Expert Talk ini yang pertama, dan mudah-mudahan kita bisa bertemu lagi di sesi-sesi webinar atau pertemuan dengan Pusat Riset Ekologi dan Etnobiologi, Organisasi Riset Hayati dan Lingkungan, Badan Riset Inovasi Nasional. Thank you very much for all participants. Sekali lagi Dr. Men, Bu Esti, Bu Resti, dan seluruh panitia yang sudah mensukseskan acara ini. Terima kasih. Resmi saya tutup. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Anang. Okay. Now we have come to Terima kasih. Now we have come to a close of the first Expert Talk series. The entry team on Data Today would like to thank us and apologize to all attendees if there are shortcomings during the event. Good afternoon, ladies and gentlemen. May we all always be healthy and see you at the next Expert Talk event. Thank you and God bless. Terima kasih, Bapak Ibu.
Mbak, Pak Meine nanti